Thank you very much. It's great to be here. First of all, I want to thank the team behind the conference for letting me speak here, for putting this all together. It's been amazing so far, so thanks for that. So I'm going to talk about how we streamlined our CD flow, and this will be a talk about ServerSide.swift, but it's coming from an iOS perspective. I'm an iOS developer myself. So there will be some server-side.swift, but most of the thought behind this comes from how I'm an iOS developer and not how I'm a server-side developer. So what are we going to talk about? I'm going to talk a little bit about myself, but I'll keep that short. Then I'm going to talk about the problem that we ran into, and then the solution we came up with and how that allowed us to streamline our flow by, well, quite a bit. So first off, about me, my name is Jari. Like I said, I'm an iOS developer at Wekamp. Wekamp is one of the biggest retailers, online retailers in the Netherlands. And I'm an iOS engineer there. I work on our iOS app. I've been working there since January last year. Not January, December last year, so almost a year now. I'm 16 years old, which might surprise a few of you and might make you wonder, like, how did a 16-year-old end up as an iOS developer at one of the biggest retailers of the Netherlands? So long story short, I've been going to school since I was 4, like every normal child in the Netherlands, but starting at 4, I didn't really fit in school. It didn't really work out for me, and the longer I stayed in school, the less happy it was making me, and well, I was leaning towards just being generally unhappy and depressed, and well, wasn't good for me. It was literally making me sick. So I dropped out of school, I think about a year ago now, where I just didn't go to school at all anymore. I started doing coding a few years back, and that was something that like inspired me and that made me see a new purpose and something that I liked doing, something that I found fun and something that drove me forward, whereas school was just like not doing it for me. It didn't interest me at all, so I didn't want to do anything for that. I started taking courses at Treehouse. For the people that don't know Treehouse, it's an online institution that gives courses in a variety of technology fields, including iOS, which is where I learned pretty much all my iOS knowledge. And I think about 2 years ago now, they launched their tech degree program, which is a predefined set of courses. With like every few courses, you have a capstone project for those few courses that will be graded by someone like from the industry. And like after 12 projects, you have a exam that when you take that, you actually get a certificate that says like you completed your tech degree, you know what you're talking about, you're now a certified iOS developer. It's not an official educational degree or anything in those like that, but it's enough for me at least that companies like the company I work at now, Wekamp, was like, okay, you have this certificate and they can see online what projects you make, and they were like, okay, this shows that you have the expertise and the knowledge that we require for you to like fit in our team and be an iOS developer. Next to that, as you can see here, I went to WWDC in 2017 as a scholarship winner, which was super cool, learned a lot of things, and that's like in brief the last few years of my life. Haven't had that many, so I can keep it short. So where can you find me? You can find me on Twitter at Low2Dev, on GitHub at Mr. Lotu, which also has all my tech degree projects there. So if you're like interested in seeing like how I made them, what I made, they're all there. They're all suffixed with TH, which stands for Treehouse in short. There are also some Python Treehouse projects on there, so don't confuse them with my iOS project because you might like, hey, this doesn't run on a phone. Which makes sense, it's Python. And then you can find me on LinkedIn with my full name. If you want to connect in there, feel free to send me an invite. So let's talk about our problem. And for any iOS engineers, let's show hands, like who has an iOS background. So that's quite a lot of people here. So you might be familiar with this flow. We first off have Xcode, then we have iTunes Connect, and then the App Store. And what we do as iOS developers, we develop our app in Xcode, and when it's done, we archive our app, we upload it to iTunes Connect, we add our metadata, we add our screenshots, we add our descriptions, we add all our fancy stuff, and then we publish it to the App Store once Apple is like, yeah, this looks good, and we are allowing you to put it on our system. And this works, but it takes time. It takes manual work. You need to archive it. When it's archiving, you can't really do anything else with your MacBook because, well, then the archiving will become slower and will take you even more time. You have to manually put in all the work of uploading the screenshots, taking the screenshots, like putting them on there, writing all your stuff, putting them on there, and then waiting for the review time and then publishing it. So in 2014, Felix Krause, I don't know if I'm pronouncing that right, came up with something called Fastlane. Many of you guys might know it, and that allowed us to change our flow to something like this. So we started with a simple terminal command which invokes Fastlane, and Fastlane is a Ruby gem that allows you to automate pretty much everything that you need to release your app. So it automates the archiving, automates uploading of the screenshot, and it automates like all the other metadata, and some other things as well that, well, you can use, you don't have to use. And then after that, we still had our iTunes Connect, and we had to release it, and then it came onto the App Store. So this was like our new solution, but we were still not quite happy with it because we had to run this on our own terminal. And while it was running, Fastlane was doing its thing, but if we started doing other things, we realized that it would become slower, and like our other things that we were doing would become slower because Fastlane was taking up like our system. So we moved to this solution. We swapped out our own terminal for Jenkins. Now Jenkins, as some of you might know, is a local hosted CI application, CI/CD application that allows you to automatically run scripts based on either user input, so you can start builds yourself, or on source control changes. So like when you push something to a Git branch, it can automatically do something, which we used for quite a while for our internal beta deployment. So when we push to our master branch, it would automatically kick off a build that uploaded our app to iTunes Connect and put it in test flight so we could test it with our release settings. And this worked, but it wasn't great. We ran into a few problems, like Jenkins is locally hosted, and so when we weren't at the office where our Jenkins machine was hosted, we basically couldn't use it. Now you might be thinking, just use a VPN and everything works great. I don't know why exactly it didn't work, because this is from before I worked at the company. This has been told me, but it just didn't work. So the only way for us to use Jenkins when we were not in the office was using TeamViewer. And I don't know if any of you guys ever used TeamViewer. It works, period. It's not great, it's not fast, it takes up a lot of data, it takes up a lot of your machine. So we were like, this is horrible. Our company was like, we want to support remote working, but we were like, yeah, we can't really do that because, well, we have to be able to tune in and like deploy our app, which is like quite important because otherwise users won't get updates and they won't see all our new fancy things. So what we ended up doing, and this is our current solution, it might seem really complicated. It's a longer flow, but it saves us a lot of time. It starts with Slack, then goes through a Vapor app that I wrote. Then it goes to Travis CI through Fastlane, and then in the end to iTunes Connect and the App Store. So this is what we're using now, and let's go in a bit deeper into this solution that we came up with. And for this solution, here we have it again. I'm going to skip off the last two parts because iTunes Connect at this point is fully managed by Fastlane, and the App Store part, well, that's just pressing your update button on your update screen. That's not that interesting. So we're going to look at these four. And first off, we're going to look at Slack. And I'm going to talk a little bit about Slack. Slack, as most of you might know, Slack is a message chat platform used for businesses, for internal communication, external communication, basically communication. And Slack allows you to create a thing called bot users, which are like normal users, but instead of an actual person sitting behind a computer with a keyboard, it's actually a program that automates responses based on input, which you can use Slack's various APIs for. They have more than the two I'm listing here, but these are the two that we were interested in because they allowed us to do the things that we wanted to do. I'm going to talk a little bit about both of them. So the real-time messaging API, or for short RTM API, uses WebSockets. For the people that don't know how a WebSocket works, I have a little example here. This is our client application, and these are the Slack servers. So when we want to set up a WebSocket connection, which is a connection between the two over which we can send data back and forth, so from client to server and from server to client, first what we do is we authenticate with the Slack servers through a normal HTTP request. So we're like, hey, we're this bot user and we want to open a WebSocket connection. Then if our authentication is successful, Slack will be like, okay, cool, have a WebSocket URL you can use for your WebSocket connection. And then all we have to do is open the WebSocket connection to that URL, after which the connection is there, and we can start sending data back and forth. Then they have the Events API, which does a lot of the same things. It gives you the same data to work with, basically, but it works different in the core. So we have our client and our server again, and where the WebSocket API is a secure connection between the both, the Events API just requires for you to open up an endpoint on your client, which Slack will just post data to. And for security reasons and a few other reasons, we were like, yeah, this is not really something we want to do. First off, we just didn't want to open an endpoint that anyone could send data to if they guess the URL. So we were like, let's go with the real-time messaging API, so it's secure, only we have the connection, no one else can just send us weird messages and like trick our system into doing things. So that's it for Slack. Now let's look at the most interesting part, for me at least, which is our Vapor application, which is doing this. So our Vapor application is handling a few things. First off, it's connecting to the real-time message API, which I just explained. It just sends an HTTP request, receives a response with a WebSocket URL if everything goes correctly, and then we open that WebSocket connection and data can be streamed back and forth. We get in the data. And then when we get in the data, we need to parse it because Slack sends us JSON, but we need to do something with that JSON. So we have a few functions here. So this is our onText handler. First off, what we do is we check if the text contains bot ID. And this might be a little bit of a weird check because if someone sends a message with bot ID, it will also just stop its execution. But this is to avoid the so-called bot hell, where one bot replies to another bot with a keyword, and then that bot replies to that same bot with the same keyword. We had this in our company, actually, where we had two bots just continuously telling each other Chuck Norris jokes, because they triggered on the word Norris, but every Chuck Norris joke has the word Norris, so that just continued forever until we like stopped one of the bots by just taking it down and building in checks to like never respond to bots with bots ever again. So then what we do is we decode this thing we call SYN data, which is basically the Slack data, but we don't really care about the actual data. So the only things we decode, as you can see here, is the type and the subtype, and then we have the E-type, which is just an enum that we can switch on, which makes it easier for us. So we switch on that here, and we check what it is, and if it's the hello event, which is basically the first event you get when you open the connection, we just print out like we received the hello, everything's fine, the connection is there. Then the interesting one is the message one, after which we decode the message data, which is kind of like this, but then not with the type and the subtype, but with the actual data that we care about, like the message author and the content and the channel and stuff like that. And then we have this call here, we say command handler.handle the message data.text with the message data. And then we have this here, which we basically ignore because, well, users are typing a lot, and if we would like log every single one of those, that would just end up like really not nice. Same with user changes. People tend to change their avatar a lot. I don't know why, but like it was spamming the shit out of our logs. And for every other event, we just print out the type that we're getting, but we don't really do anything with it. So let's look at these commands. We have here our command handler function. This is the handle function that we talked about earlier, and the command, I couldn't fit it on here and have it still readable. The command is just a struct with an array of strings for triggers, and then an execute function, closure, which takes, as you can see here, it takes in a socket, which is our actual socket. It takes in arguments, which is everything that comes after the trigger for the command, and then the actual event data. So this is an example command we have here. We call the register function, which just appends it to an array, pretty simple. And then we have here our closure. So when we send in a command with this trigger, ping, which would be your command prefix ping, then we get into this handle function from our text handler, and we check if the message starts with our prefix. In our case, this is usually an exclamation point. And if it doesn't, we just discard the message. We don't care about it. Then we take the message, but without the prefix, because, well, the prefix is just there, but we don't really care about it. It's just to indicate that it's actually going to talk to our bot. And then we take all the components, split by spaces, and then for each command that we have registered to our command handler, we check if the triggers for that command contain our first component, which is the command name, so-called, or the command trigger. And if it does, first off, we just log some info, and then we execute the command, and we pass it down our real-time messaging sockets, the components, but we remove the first one, and the data we get in, which is the message data. So this is how we parse our incoming data and decide what we want to do, but then we have to do it, so we have to respond to commands. So let's take a look back at this ping command that we have, and we say here socket.sendMessage, which is a helper function we declared on our socket, which sends a message, as you might have guessed. So what it takes in is takes in a channel, which is a string, and then the text you want to send. It creates some headers with some authorization, and then it posts to the Slack API endpoint that posts a message with those headers, with some body, which takes in the channel, the text, and another parameter, encodes that, and then that will end up looking something like this. So we have here, I say ping, and our bot is like, at the same time, it responds with pong. And this is not really a useful command because it doesn't do anything, it just replies. But you would be surprised how much this is used. Like before every real command we use, most of the time this one's executed just to check if the bot's actually online, up and running, if it can respond, because if not, well, we can execute whatever command we want, but the bot's not going to do anything, so we know we have to like reboot it, like check what's going on. And then we need to make some magic happen, because just responding to a message, that's not going to deploy our app to the App Store. That's, well, just some fun stuff you can do in Slack. So, for example, we have this here, which sends a Travis command to Travis, and I'm going to talk a bit more about Travis in a little bit. So what it does, it takes in a branch, a script, a message, and a repository. It makes up some headers for Travis, and then it sends an HTTP request to Travis with the data, and then if we get a response back that works, we're happy, and Travis will do its thing. And if not, we'll just log, like, hey, Travis did something stupid and it exploded. Check the logs if you want to know why. So this is something that gets used for our flows. So when we execute certain commands, like our release command, it executes a Travis build, after which Travis handles the actual releasing. So let's talk about that next. Let's talk about Travis. So first off, I want to talk about what's Travis. So Travis, like Jenkins, it's a CI/CD platform, but has some big differences. First off, Travis is cloud-based, so you don't have to run it locally. It's already there, it exists, has a beautiful website, works great, and and you don't have to configure anything on Travis website. You configure everything in your repository with a so-called Travis file. So this is an example of a Travis file. At the top we list, okay, I want to only do Travis things when I push to my cool branch or my other branch. Then I set the language for this project, Swift. This is my Xcode workspace, my Xcode scheme. My OS is OS 10. My image is Xcode 9.4. And before you start installing anything, which by default, if the language is Swift, it will run pod install if it detects CocoaPods. But before that, I want you to update the CocoaPods repo. And then the actual script to build this is going to install XePretty and then Xcode build the entire project to see if it compiles. So this is a pretty common setup that you might want to use, like, for example, if you open a pull request, you can configure it to build when you open a pull request, which will trigger a build and see like if it compiles after the pull request is merged, and it will give you a nice green check mark on GitHub. And if you get a nasty red cross, you know, like, oh, I did something bad in my code. If I merge this together, it's not going to compile. And then you can check Travis output, like what's not working, and you can fix it before it's on your actual master branch, which is really nice. So why did we use Travis? Well, for most of the reasons I already mentioned. It's cloud-based, and it's a very easy setup in your repository. So let's look at Travis and Jenkins, because I talked about Jenkins earlier, and why did we switch? Well, basically because Jenkins is, like I said before, locally hosted, so it requires either a VPN, but for some reason that didn't work for us, or something ugly like TeamViewer to connect to it. If the power cuts out on your office, for whatever reason, your entire flow is just down. And you have to set everything up in actual Jenkins, like the actual project steps are in Jenkins, and to change them, even if it's just a small change, you have to log into Jenkins and update them there. Whereas with Travis, it's all remote, so if it goes down, well, everything goes down, but Travis will make sure that that doesn't happen, hopefully. And everything is set up in your local repository, so you don't have to touch Travis website to make Travis work after you've done the initial setup and added your GitHub repo to your Travis organization. You can just push, everything works. But if you're like, hey, I want to update my script, you can just update your Travis file, push again, and Travis will do something completely different without you ever like opening your internet browser. You can just do this from Xcode or VS Code or whatever IDE you prefer to use. Next, I want to talk a little bit about separation of concerns. Like, as programmers, I assume we all know like one thing should only do one thing and one thing only, and it shouldn't like do half of another thing too. So what we did is we split up our giant app repository into two. So we have our app repository and we have our metadata repository. Now our app repository holds our code and a Travis file, but this Travis file is only used for checking pull requests and building the bad app builds, so adding them to test flight. Then our metadata repository actually holds all our Fastlane required files and a Travis file that we use for our release process. So they're completely separate. You can update the code without like having to check the metadata repository. You can build metadata builds way faster because you don't have to wait for like all your pods to be installed and like other things that Travis automatically does when it sees a pod file somewhere, which speeds up build times by a lot, which has allowed us for us to just work way faster. So let's finally take a look at Fastlane, which is basically the most important part here. It's the part that actually does the heavy lifting. Like the first three parts are just gluing things together, whereas Fastlane is the actual thing that does our things. So first off, what is Fastlane? Like I just said, it's a Ruby gem. It's really cool. It allows you to pretty much automate your entire iOS process except for coding your application, which is really nice because, well, as many iOS developers probably know, you sometimes have code signing issues, which are amazing and really hard to resolve. But Fastlane takes care of this in a really nice way, where you can have a GitHub repository which just holds certain profiles and it injects them into your app, which works for like CI development, but it also works on your local machine, so you don't have to create 80 profiles for every developer, have a single profile that works for them, but then if they switch to another machine, they have to create a new profile or download their old one. It's just a hassle. So Fastlane is just something that really allows you to speed up for your iOS deployment. So how do you configure Fastlane? Fastlane works with a so-called fast file, which is a Ruby file with a custom name. And in those fast files, you define lanes. And a lane is something that, well, you could say you drive down when you do a certain action. So, for example, we have here our beta lane. So the description is pretty obvious. It submits a new beta build to Apple test flight. And then we say here, okay, so for this beta lane, what we do is we first get a build number, which is the same as the Travis build number, which gets auto-incremented by Travis every time, so we don't have weird conflicts on iTunes Connect, which will say like, hey, you already have a build number that's higher than the one you're trying to upload now, we're not going to do this. Then what it does is, this gem action is actually creating our app binary. And then what we do with this pilot action, they use big confusing naming, but what it does is it uploads it to iTunes Connect and it submits it to internal test flight. So like when this is done, after Apple has actually finished processing the test flight build, which sometimes takes a while, like we get just our notification on our phone, like, hey, new test flight build's available, and we know like everything's working. And then what we do is we push some Git tags just to like, for us to be clear which build is associated with what code, so we can actually like check if we see, hey, this build does something weird, we can check where in the code it does that weird thing and we can fix it. And then it notifies us, which is really nice, so we can actually like see when our Travis build goes well or when it fails. Then we have our submit build, which is one of the most important builds. And this one gets triggered through Slack. Like we execute a Slack command, we say submit, and then we give it some parameters like the build number, the version number. And if we want it to be a normal release or a phased release, then Fastlane just takes those parameters. It delivers the app, which deliver is another Fastlane action that's kind of weirdly named. What it basically does is it submits your app for approval to Apple. So it takes an already existing build number and version from iTunes Connect that you already uploaded through the beta step. You don't have to do it here. You could also like use your pilot action like right in here and upload it first and then submit it. If you don't want to do the whole test flight thing, that works fine too. So it submits it, and then when it's submitted, it sends out a little Slack message so we can see, oh, the build's submitted, it's in Apple's court now, and they can, well, do whatever they want with it. And then our last lane, which is the easiest lane, the most complex lane, but the most important lane as well, is our release lane. And all it does is it logs into iTunes Connect, which is now actually called App Store Connect. Then it finds our application. It takes the version that's the edit version, which is the version that's pending to go live, and it releases that version. Now, you might see the exclamation point. I don't know why it's there. If you don't use it, the Fastlane command is not there. Like, it's literally called release with an exclamation point. It might be a bit scary for us Swift developers, because you're like, why are we forcing this? Like, what? But what it actually does, it's just called that, like, ask the Fastlane guys why it's there. Oh, it's a Ruby thing. Well, ask the Ruby guys why it's there. I don't know why it's there, I just use this. So what it does, like, if you don't have an edit version, like you don't have a version submitted or Apple hasn't finished reviewing it yet, it will just give you back a Fastlane error that says like, hey, you said find this version that's ready for release. We don't have a version that's ready for release, so what are you doing? And it will just fail and not release the version because, well, there is no version to release. If we do find the version, we release it and we put it on Slack like, hey, we've released this new version, go check it out. And like within 10 minutes, it will be available on the App Store because Apple takes some time to update those things. So that's it for Fastlane, which basically concludes our entire flow. But now we have this flow, and well, now what? Because we have this, but it works great, it does its job, but we're like, we don't want to just keep it like this. We want to expand this. And what we can do is add more integrations. Like, the possibilities are infinite. So what we did, as an example, is we integrated GitHub through our bot with Jira, which is what we use for our stories. So what we did is when a GitHub pull request gets closed, you can configure GitHub to send webhooks, which basically means that if you do something on GitHub, it will send a post request to a certain endpoint, which will contain JSON data with certain things. So we send that payload when we close a pull request to our application, which parses that data, and then what we do is we check if that pull request that we just closed, the branch that we merged from, has a Jira story assigned to it. And if it does, what we do is we just close down the story, say, okay, this story is done, we merge the pull request. We set the fixed version, which is really nice, so we can have an overview of like what version will this be when we go live, and be done with it. Which before we had to close the pull request, then log into Jira, find the story, close the story, set the fixed version, and then we were done. Whereas now we just press one button, which is the merge button, which actually requires two buttons because you get a confirmation, but you get what I mean. You merge the pull request and everything gets handled behind the scenes, and you don't have to even look at it, and it's just the story is closed, put on done, versions assigned, and you don't have to like look at it. And there's like, this is just one example. There are millions of other ways you could integrate your Vapor application with whatever applications you are using to just make your life, make your day easier. Like, take as much boring small tasks away and put them in your application so you don't have to do them yourself, and you can just focus on coding your app, which is the thing you actually want to do. At least in my case, it's the thing I want to do. I don't want to spend my day closing Jira issues or submitting builds to the App Store. So that's been it. I thank you all for listening. And if there are any questions, I'm happy to answer them.